it is difficult to resolve, and it is difficult. It is not cheaper also, and it is also taking too much longer time. So sometimes that point are missed out, and we say that now there is no any option to resolve, and we cannot now comply that point. So it is best is we have to conclude it before installation and before procurement. It protects the people, environment, equipment, and company reputations. So basically, people, equipment, environment, we all know it, but some of the reputation is much important for all the industry. Right now, I'm in India, and I can say that it is not. I would not like to say that, but some of the industries, when we are taking the name that yeah, so XYZ company, there is a vacancy, and you would you like to go? The people say no. I'm not giving my life to that company, because there is a reputation and there is a bad reputation. So it is very bad impression about the company. It many countries it is a legal and regulatory requirement. So basically now the legal and regulatories are more strengthened, and because of that we can see that there are so many major accidents and disasters are there. So the regulatories are also very strengthened to comply that all the HAZOP studies. Yeah, anything it is some suggestion you can just give me between that presentation, so I can much more faster also you can suggest me.
Sir, good afternoon. This is okay, sir. It is not too fast or no, not too slow. You can go at this pace. Thank you.
Okay, thank you so much. So basically
Sir, 1 minute.
sometimes yeah,
You can elaborate little bit process hazard analysis and QRA
yeah,
are correlated. These documents also very one of the key documents for further to analyze as of study.
yeah, it is also part of the particularly in HAZO when we are break the process. So particularly a storage part is a much covered in for the QRA, because there is a bulk storage and there are the more hazardous area that bulk storage is there for the raw material and particular chemicals. At that time, it is a particular pH and QRA is also major part of the HAZOP. So in next some couple of slide, I will brief you that where the QR is covered in the HAZOP also. Can we move?
Yeah.
Okay, okay. So
Excuse
basically,
me,
this
excuse me,
document,
this is Prakash.
uh,
Hello.
yeah, yeah.
Excuse me, this is Prakash. Uh, Only these are the documents required or any other documents in the next slide?
This is a basic documents when we are conducting, but some of the documents should be also covered during the HAZOP. Like we can say that QRA, as well as some of the like we can that suppose sometimes it is a some testing are required, like we can say the, minimum ignition energy MIE, that are the documents, but it is a part of some particular risk assessment during
Yeah.
the
100% you are
some
correct. 100% you are correct. What I feel, one more document. You see, whatever we are discussing, everything is healthy discussion. Okay. Now,
yeah, yeah,
process description also basic thing could be required for this HAZOP, right? All the
yeah,
document,
right,
whatever you have mentioned, it's good. But I feel personally, and process description, without process description, all these documents we have, but process also we should know along with all these documents. That's what just one
Yeah,
point
yeah.
I would.
It is some word difference, that there is a, I mentioned that provisional operational instructions. So we right at here we are saying that some of people are that
Hello.
process descriptions.
Hello.
Yeah,
Good evening.
Good evening, sir.
yeah,
This
please.
is
Uh,
This is Siva Prasad Rao from Visakhapatnam, Andhra Pradesh, India. I would like just to add one more sentence. Apart from the given list, and also as you said, SOP, that provisional operating instructions. If it is added that previous instance list or any instance such incidents are there, if you add that also, that will give more information, because all these things are there. But previous any incidents are there, or any near misses are also there. If you consider them also, it will be somewhat better. I think so, as per my experience. I am from Coromandel, Visakhapatnam, Murugappa Group. Thank you, sir. Thank
Okay,
you.
okay, okay. Thank you, sir.
Sir, good evening.
Good evening.
Sir, this is Jayanti, Dr. Jayanti from Visakhapatnam. Okay. I'm a EHS
Yes,
consultant.
yes.
I worked for 24 years in Gulf, Abu Dhabi, Saudi Arabia, and Qatar. Your intention of starting this hazard and operability study is good. But what I suggest is, just as Mr. Shivaprasad spoke to you, I know that you are working on
Hello.
We can't hear. Is somebody
Hello.
asking a question?
Yeah, is it
Hello,
audible?
Yes,
everyone.
now audible. Yes.
I request everyone to wait till the speaker speaks till the end of the slide. Okay, then we can put questions. Okay, sir.
Yeah, it's better, sir.
Thank you.
Yeah,
Thank
better
you.
let the speaker to finish the
Thank
presentation
you.
really.
Yeah. Please
Thank
go ahead,
you.
sir.
Sir,
Yeah,
one
Thank you.
thank you, sir.
this is Maksood from Kuwait. One of the basic document I believe it is missing in the list. This is basis of design.
Yeah, exactly. Yeah. Okay, these are basic documents actually. So during that operation, some of people say that we can conclude also some include also some accidents and past accidents. So basically, the process are different. So process accidents are different. So basically, we cannot copy paste some of the accident. We can learn. We can say that we can learn and we can take it as a model also, but we have to develop our own processes, and we can also take some similar processes which are followed by any our other industries, so we can take that references also. So basically that's our common document MOC, management of change, process flow diagram, piping and instrumentation of the diagram, equipments, graphical designs, layout diagrams, interlock lists, material safety data sheets, provisional operation instructions and process instructions, heat and material balances, and equipment data sheets, startup and emergency shutdown processes. So that is a these all documents are basic documents to start and conduct the HAZOP. The whatever the documents you people are suggested is also part of the HAZOP study. So it's depend upon the that processes. So many documents are the part of we can say that intermediate of the documents. Okay. So we can say that now on coming to the forward that some what are the terms we have to use, the key terms. That's first is a node. Node means the one section of the plant that we study at a time. Like suppose, just giving one example, that one of the vessel or tank is there, reactor is there. Normally we are pumping the material to another tank. So this particular part we have to take for the our study, for the HAZOP study, and we mark it as a node. So this particular part, we can say that the node 1, node 2, whatever we to move the further process. So basically the node is a part. Second is a parameter. So what are the parameters we are using, like flow, pressure, temperature, level, even there are lots of parameters in that. Particularly we can say like time also, even we can say that what some other parameters depend upon your processes. So that basic parameters are level, flow, pressure, temperature. That is our basic parameters. Guide words, that we have already said that the 7 guide words we have to apply for the all the parameters, like no more, less, as well as more than. So that all the guide words should be applied for the each parameters. Then deviation. So basically we have to identify for the each guide word, that suppose that we have mentioned that the flow, so we have to mention that if there is no flow, what will be the deviation. Second thing, suppose more, if the flow will be increase, more flow, then what will be the deviation. So we have to I have the one format we will discuss on later on, so it will be good visible to how it the that parameters are work, and how the deviation will work. Then consequences. So what are the consequences if that process will deviate? So what bad things can happen because of that deviation? Suppose one of the guide we are using the parameter using flow, and due to that flow deviation, what bad things can be done. So that will be in consequences. And for all that consequences, what are the safeguard we have provided? That will be the in safeguard part. So basically that is a key terms for the HAZOP. So basically these things are the hazard versus deviation in this process. So the hazard is something with power to cause a harm. So, what are the harm due to that particular activity and particular that process will be the hazard, the, like flammable materials like fuel and solvent, toxic gases, high pressure and high temperature reactions, any reactive materials handling, hot surface or rotating machineries. A hazard is always there. We must control it. We can say that what are the process we have defined, predefined, there is a much less probability to eliminate or any substitute, because when we are on stage of the HAZOP, so we can say that we already try all the things that we can eliminate and substitute, but there is no possibility of that to eliminate. So ultimately we have to go for the best control, which is engineering control. So we will look forward that how the engineering control will work. Then the deviation part, like process going away from the normal. So what are the parameters and what are the design criteria we have defined? So during that process it is not match or it is deviated, that can lead to the any minor, major, any type of disaster or accident. So there is some what we have discussed, that the parameters like no flow or much flow, pressure is it is high or low, that we can say low pressure, that means that vacuum, if the any tank get pressurized also, but in case of the vacuum what can be happen. Temperature is the same, if the high temperature and low temperature, what can be the scenario due to that parameter will deviate. Level also high and low, and same, the deviation plus hazard will be the possible option. If hazard and deviation are will come together, the accident can be happen. So that the two things we have to consider more critically during the HAZOP study. So guideword and process parameters. So basically, we have already discussed about that guidewords, but we can move forward because we in previous slide we discussed about the pressure and temperature and guidewords. So now that guideword, what that mean, and so giving some examples. Like suppose we are consider that no means whatever the flow or whatever the things we have parameter we are considering, there is a no design intent to achieve that particular parameter is not coming there. So no flow when production is expected. Suppose one of the we have just taken that example that one of the material is transferring from one tank to another tank. At that time, any of the reason, any of the deviation due to deviation, suppose the flow is not coming. So is there any particular impact due to that particular for the risk? So it will be for the no word. Second is a more. This is a meaning that the quantitative increase. If the quantity will increase in any of the like flow, temperature, pressure, then what will be the consequence? That should be defined. Same thing, the less. Less means suppose the quantity will be decreased. If the quantity is lesser, then what will be the consequence? Like suppose pressure will be low, flow is, will be lesser, temperature will be lesser. So what will be the particularly deviation consequence due to that deviation, as well as an additional activity occurs other wall close and same time. Sometimes that we can say that as well as means there is a human error. So there only we have to open one wall particularly, but by misoperation any of the other activity also started at the same time from the same equipment or same node. So it is a two activities happen at the same time. Part of only some of the design intention is achieved. Only part of the system is shut down. Some of the things that we conclude or design intention for the particular some part, but it is a some other systematic system also interconnected with that particular part, and that can be result in any of the risk or any of the accident. Then reverse means logically opposite of the design intention. Suppose we have transferring the flow from one tank to another tank, but somehow any of the due to some any reason the flow is coming back to that particular equipment reverse back. So any of that reverse logics will be also considered during the design part. Other than complete uh, substitution, another activity take place. Like suppose we are transferring, there are some pressurized reaction and some of the chemicals liquid to CO, liquid CO to liquid isobutylene. Any of the gases, liquid nitrogen, they have two properties. We can use it gaseous form also, and we can use also in liquid form. So in that case, but suppose the transferring is we have to use the liquid form, but somehow it is coming with in gaseous form also. So due to that, any of the consequences can be happen. That should be also considered. So basically, what the HAZOP had to be conducted is based on that guidewords only. That seven guidewords. Uh, s- some more word we can also use as based on our processes like unclear. Suppose sometimes we can say that our any of the equipments, any of the process changeover we have, then the main part of the that equipment and the process should be clear, but it is not clear, then it can also be lead to any accidents. Steps in wrong places, process will lead to action out of correct sequence or recovery fail. Suppose we have to charge the three materials A, B, C, but we have to charge first A, then B, and then C. But due to some wrong step and wrong operation, the B material is charged first, and then we have charged material A. So in that condition, any of the wrong charging of the material can be lead to any accident or any failure should be considered. Wrong action, specific actions, like sometimes any of the process deviations, any process parameters what we have designed is failure, but at that time we sometimes we say that nothing will be happen, we can take the risk. So that wrong action should be defined. Incorrect information, sometimes there are the gaps in during the design stage, during the research and development stages. So that is should be defined in information, like what the sir said, that uh, in information part for the process hazard, PSM, so it should be covering process information. Step omitted, missing step or step too large, requiring too much of the operator. Like sometimes that some of the solid part that in process we have to add for as a agent, and the people or any operator missed out to chart that material during the operation. So due to that, any of the consequences can be done, and that can lead any major accident should be also we can use as a guide word. Step unsuccessful, any of the steps we are defined in that particular process, and that step uh, not succeed. Suppose we are trying first batch, or any process is very critical into parameter, and if it's fail, due to that failure can lead any accident, or what will the consequence due to that failure should be defined. Interreference effect from the others, procedure following performance like to be affected by other personnel carrying out the simultaneous tasks, unusual when co-located. Sometimes that we can say that procedures, people are not following the procedures. We can say that already in cover above point, a humor error. So it is also covered into that HAZOP study. In the guide what we can use this, but it is based on your what we know, whatever the step we broken for that nodes, and what are the processes we have covered into step by step. So also that some of the word we can also use that time. In that case, particularly if the exothermic reaction is there, and particular we have to provide some cooling media particular timing, that should be in cover into time. If it will be more or less, then what will be the effect and what will be the consequence. Same the sequence, suppose we have to add first solvent or chemical, then after we have to charge the powder. But if any of the people is the sequence will be uh, alternate, then what will be the consequence should be defined. Procedures not available, not applicable, not followed. So most of the cases the procedures are deviated and not followed because it is a there is no any control. It is a, we can say that self discipline is the matter in that to follow or not follow. So like we can say that the helmet is a compulsory to wear, but it is a self discipline, the people are wearing or not. So this procedure should be part of that HAZOP word. Measurement, instrument failure, observation error. So in HAZOP study, most of the time we are taking that we have provided some level transmitter, pressure transmitter, and there is a measuring equipments, instruments are there, but we are 100% liable on that instrument. But in case of that instrument will be failed, then what will be the consequence? So that also be considered in HAZOP study. Organization, unclear responsibilities not fitted for the purpose. Sometimes there are so many co-factors are there regarding the management organization. So there are some other factors like priorities, production priorities, that are also in the affecting to the our operation. So that also should be considered in during the HAZOP. Communication, failed equipment, insufficient, incorrect information. So basically, sometimes the communication is not done if any equipment instruments are failed. So at that time, uh, it should be informatively pass out to the concerned person. So it can the any of the miss operation or accident can be prevented. Person, person lack of the competency to few too many. Sometimes the skill is not available. The person is not competent. The person is not trained. So that is also the part of the operations. Positions, wrong position, movement, excessive tolerances. We can say that is a part of risk assessment, but at some level it is covered under HAZOP also. Power, like complete loss, partially loss, means basically we can say that the utilities and that all the things in case of in operation, if the utilities will be goes down, then what will be the consequence? Same is a weather. Sometimes that the weather is a we are not considered like very in we can say that during the winter season there is a possibilities of fire is much more in particular process area because of static charge generation and that all. So during that weather condition also sometimes lightning also. So one incident there one of the industry was installed the lightning arrestor nearby the raw material solvent storage area. Due to that, in the monsoon season, the lightning was captured by that tower, and due to that, the raw material storage area will get the fire. So that should be also considered during in the weather part also. This is only list that some of the parts are also we can cover like flow, pressure, temperature already. Sometimes mixing also there is a the mixing is completed or not. If the not mixing properly, that can be lead any accidents or any miss out of parameters. So in process sampling is required or not should be decided in mixing. Stirring same of the thing. In case of the stirring will be not done, agitating is not done, so it should be also considered. Sometimes we can say that the we have in DCS on DCS we indicate that there is a agitator is moving, but suppose agitator is disconnected with motor, so how can we ensure that by DCS? So we have to display that what are the ampere is taking, what are the RPM is going on. So we can assume that we can show that control that there is a stirring is going on. Same is transfer level, viscosity, reactions, compositions. If the any compositions are there, any additions are there, any separations are there, it is done properly or not as per our process. Then speed like RPM, I have told you. Particle size. If we are preparing any solid parts, we are making any of the process part in particular particle size, so it is also should be considered due to for that dust explosion and that point of view. Measures controls, it is already we discussed. PH and sequence. Sometimes some of the process pH is also matter for that. I have worked with one of the chemical industry, petrochemical. So during the normal pH, there is no any generation of that process S2S from that process. But in case the pH will goes down, and if the scrubbing system is not working or any of the people is not observe that particular part, then S2S will get deliberate. And one of the accidents is happen, and three people are also affected due to S2S. So pH is a matter. So during that accident, that the industry is installed the online pH meter into the scrubbing system and that particular part. So pH is also the part of the HAZOP study. Operate, maintaining, servicing, and communication. These are basic words we can use during the HAZOP studies. So the what we have discussed, the step by step, that word we have discussed earlier, that this is a flow for that step by step. First of all, we have to select a node, whatever we have the PNID, and what are the points, whatever the part we have to cover should be, first of all, should be covered into one section in the, we can say that in a node. Second is understand the design intent. What is the intention for that design and what is the understanding? So it should be mentioned that what is our intention. Apply a guide word and get a deviation. If we are using that guide word, we can get the deviation. Without guide word, we cannot get the deviation. Then possible cause. What are the possible causes due to that deviations? Then think the consequences. What are the consequences due to that causes? And what the existing safeguards we have, what we have safeguards provided in the particular process. And after, if there is any gap, there is a risk matrix. So we have whatever the risk should be considered by quantitative method. So we have some figure that indicate that this is a high risk or this is a low risk or medium risk, moderate risk. So after that, if it is a moderate or low risk, we can move forward with, and without any recommendation or any operations, or without any safeguards, with our existing safeguard. But if the risk will be high, then it is a recommended and some records and something that we have to improve or implement to improve more safeguards there. And after that, final repeat to every guide word and every node. This process should be applied for the each and every node. So basically, the HAZOP worksheet documents. So this slide I will skip because I have a worksheet in next slide. So we will go with that worksheet. So we can move. One example I have taken that particular for that. Suppose we have one reaction with the pressure and temperature. I just put the number in that R101. So reactor 101 has a pressure and temperature. So what is the causes for that pressure and temperature? There is an exothermic reaction, and consequences is the reactor will be pressurized. This is a consequence. So what are the safeguards? Suppose whatever the pressure, operating pressure, and what is the design pressure for that reactor? First of all, that should be considered by your GA drawing or designing part. There is a pen, pressure transmitter, pressure indicating. The two things are provided for that particular reactor to indicate and to observe pressure. Pressure safety valve and rupture discs are provided, PSV and PSRV. There are two PSRD and one PSV is provided for the emergency. To if any pressure is if any pressure will be built up, then the rupture disc and PSV will pop up. Then for the exothermic reaction, the provision is -20 degree chilling provision into the reactor jacket. Second thing is a flow. The exothermic reaction is due to the flow. So there is a flow is provided, flow meter is provided, flow R is provided. The solvent is stopped by the XV if the pressure increase in reactor. So it is a linter lock. If the flow is increased, then if the temperature will increase, if the pressure will be increased, the charging line, whatever the solvent, ABC solvent is there, it will be stop addition by the closing of control sorry, auto valve, XV valve. So I'm just giving this example because of many of the people in industry we are conducting the HAZOP during the existing safeguard. Most of the time we are mentioned that there is a human error, and same time we are mentioned the safeguards, existing safeguards are, we have a trained operators, we have a supervisor, we have a operating procedures. So this is a meaningless, I can say, because of, if we are considering the human error, then it is 100% possibility that what the safeguards are, that will be the deviate during the control measures. So it is not part of the HAZOP. Basically, the we during the HAZOP we have to consider mostly 90% cases we have to provide the engineering controls only. Sometimes like where tanker loading unloading part is there, then at that time we have to apply for the 4I principle. So we can two people or four people can cross check and verify that whether the first person is doing his duty properly or not. So basically this example is giving by me for that particular reason, that what the existing safeguard, here I mentioned that only the most of the, six engineering controls are there to prevent the pressurized reaction. So if I mention here, there is a pressure gauge and the supervisor is there to monitor that pressure gauge. We cannot reliable on that control measures, because if he is going for the food, for the washroom, at that time who will take care of this reaction? So basically, that point should not be in part of the safeguard, for my point of view. But depending upon that process, this is our risk matrix, what which I follow, and in my previous industries and in my experience. So basically, it is difference from company to company or consultant to consultant, and depending upon the SOPs. So basically, this is a risk matrix. First of all, you can see that there's a quantitative approach. This is a frequency per year. So this is our past, whatever the uh, historical data we have. So we have to identify from this column, like unwanted event have occur in the specified time of operation within this industry using this same technology. Same unwanted event almost certain to occur in this specific type of operation within these industries using the same technology during the life of the operation. So there is some word difference for the evolution of the quantitative approach for the historical approach. Same thing is mentioned here. So basically, if you have any engineering controls are there, suppose there is no safeguard to prevent that even, then you have to put it rank of the 5. Suppose you have a single safeguard with the engineering control, you can mention 4. If there is a 2 safeguards, then we can mention the 3. If you have a more than 4 safeguard that lead to one failure, can be 3, can be allowed to understand the scenario. Like you have a, 2 pressure transmitter and one safety valve. If any of the one of the things is failure, then second will be take care by for the that pressure reaction. So if the type of safeguard you have four or more than 4, then you can get the credit of 1. So you have a much probability of that uh, pressurized reaction or any mishappen or any accident due to that pressure reaction, because you have a multiple safeguard installed in that particular part. So this is a for that particular for the likelihood, and same is for the severity. So basically the severity based on that property damage also, and human injuries also. So for the human injuries, suppose minor injuries or illness due to that particular accident or a particular movement, that it will be comes into 1. We can say that bottom of that severity, it is on second page due to that space 1 2 3 4 5. Same is here is a 1 2 3 4 5. So if the medical treatment and hospital administration due to that incident, then it will be covered under the that type of severity will be in 2. Permanent disability will be in 3. One fatality will be 4, and more than one fatality will be 5. Same will be the for the property damage from the outset facility damage and environmental imperial also. So in that you can also add more than that columns and more than that effect. You can also that if the any other industry has a three in reportable accident, then it is also acceptable. So it is based on the industry and what the procedure you are following. So This is like one of the case study. Sorry. Can we? Can I show you the format what we have discussed right now? Is it visible?
No.
Yes, sir, it is visible.
Only your slide is visible, not the format.
Okay, just a minute. Yes. Is it visible? Or?
Yes, now it is visible, sir.
Yeah. So this is a format what we are using right now. So this is a reference number of the drawing. First of all, we have particularly in step by step for the node one, and this is a drawing number. So PNID number. This is a revision number, and this is a date for that particular drawing for the PNID. Second is a HAZOP team. What are the team members are there in the study? This is a part consider. So this is a mentioned that ABC type solvent is transferred from this tank to this reactor. So this is a uh, things that is a part considered for that node one. And this is a activity here mentioned that ABC solvent transferring, solvent addition, then material. This is a material and source. This is a source from this tank to this reactor. Okay, and this is a design intent. So we have considered pressure, temperature, flow, vacuum, loading, unloading part also, transferring, loading or unloading. That part is also considered. Utility failure is also considered. Static is not considered. MOC not considered. Quantity is considered. Emergency considered. So whatever the parts and intents we have using we are designed, it should be this is a summary that we can get the data that yes in this node we have considered that all the parameters. So basically first of all the parameter is at here is a flow, then this is a guide word. So suppose there is no flow, so what is the deviation? No flow from 2051 tank to 101 reactor. So what is the cause? Why the flow is not coming? First of all, maybe there is a tank is empty. Second, the valve or pump or any of the control XV valve, the automation valve is stuck or it is a closed. So basically, this is a process delay. There is no any consequences due to that particular cause. Like if the material is get not transferred, there is a process delay. Nothing the safety risk is there. Same thing in that case. Same, second is a flow. Suppose more flow from same tank to reactor. There is a possibility of control valve, flow valve or XV valve malfunction. So due to that, if the control valve decided that it should be a 20% opening, but particularly during the operation it goes to 30 or 40% opening due to any of the mechanical integrity. So due to that, what happen if the material charge more in shortage of time, then it will goes the exothermic reaction and the reactor will goes to the pressurized. For that control, what is the existing safeguards? So this is a temperature indicators are there, temperature transmitters are there, and which is interlocked with the transferring auto valve. So in that case, suppose temperature is increased, that it or any pressure will be increased, it will giving alarm also, as well as the valve will be closed. Same, when the temperature increase, due to that temperature, if the temperature not beyond to that and convert into the pressurized reaction, so minus degree temperature, like we can say that the brine temperature is given to control that heat temperature. Same process, pressure indicator and pressure transmitter are provided. Same thing is there, the pressure safety valve and rupture disc are provided. In that case, this is an existing system, and based on that, there is a severity is high because of pressurized reaction is there. But the likelihood is much more lesser due to there is a more than four controls are there in the particularly this deviation. So the risk rating is only 5, but there are some, this is acceptable in that case, but we have to we have some hidden risk also, that we have to know about that what are the process parameter can be deviated due to if the reaction will be on the pressure. So there is a different thermal shear analysis DTA test to require for the reaction analysis. When the temperature, what is the temperature limit? Suppose our temperature will cut off is 45. Beyond, when it reach to the 45, it will be run away reaction. That should be know about in before that batch transmission and before that process. So that should be a lab trials, and in that lab trial we have to know about that what will the diagram for the pressure and reaction temperature, and that if the pressure and pressure will be raised around 50-degree temperature, so we have to control it around 40-degree temperature. So we cannot go to the 50. Same thing, suppose that the pump shall be stopped, for that XV will close, otherwise the line pressure will be increased. In that case, the interlock was provided that the valve will be closed, but we are controlling one of the incident, we can preventing one of the accident, but similarly we are inviting the second accident. Like suppose the pressure will be continuous, pump is continuous operating, and we have stopped that valve in that line. So the line pressure will be increased, and flange joints leakage and that all the things can be happen, or maybe the pump fire also can be done due to overheating. So this is a also should be covered in that recommendation. Even we can say that the risk rating is 5, it is acceptable, but some of the hidden parts also should be covered by during the that HAZOP study. So this is one of the example. So this is a flow, same is a pressure, same is a temperature, same is utility failure. So if in case of utility failure, what are the parameters, how you can monitor? Like suppose electrical failure is there, so temperature increase into reaction due to supply of the chilling system. So what is the provision is there? So auto DG set changeover available. In case of power failure, within a 2 minutes it will be operating by on the DG set, diesel operated generated pump. Then high temperature and reactor, then solvent addition will be automatically closed in case of power failure. Alarm raised in case of chiller failure, or chiller TT. Chiller, there is a provision for temperature transmitter also in the chiller, whatever the chilling system is provided. Same in case of chiller failure. So there is a numbers of controls are there in case of failure of cooling system. So that control should be covered during that PNID review and during that HAZOP study. Same thing is there. There is a exothermic reaction, and its quantity is a matter. So quantity here mentioned that is the more quantity will be charged in the that particular reaction, what can be happen? The sequence provision with the batch quantity transport means there is a provision that only 500 liter of the material should be transferred, that the sequence not more than it will be charged due to that in that DCS system is provided. So there, that time of same thing, there is a time also considered. If if the material is charged faster into shortage of time, then what can be happen during the reaction? So it is also covered in that part. So sequence, there is a provision, flow meter is there, flow transmitter is there, uh, double TT temperature transmitter is provided with the two number of transmitter provided, and chilling system is there. So there are multiple controls are there. This is a before analysis, before risk rating based on existing controls. After that, we are providing the grade ABC by providing that risk matrix. If additional recommendation is required, so it is mentioned here. And after completion of that risk rating, we will go for that uh, again for the reducal of risk. What the risk we have reduced before and after will be calculated after that compliance did recommendation. Is it okay?
Yeah.
Yes, sir. Go ahead.
Yeah. Okay.
Yeah,
So
yeah, Dr. Sap,
yeah,
shall I ask later on or shall I ask now?
yeah, we can right now.
Yeah, sorry to disturb you. Now here two questions I have, right?
Yeah, yeah,
Maybe healthy discussion. This is only, it's not a fault finding, right?
yeah.
Now the
Yeah,
initial risk, you are giving the before controls. Am I correct?
yeah.
Am I correct?
Yes. Is it visible right now?
Yeah, it's visible. Your
Yeah,
this table is visible, chart is
yeah,
visible, whatever your this thing is there.
yeah,
The initial risk you are giving the before controls. Am I correct?
yeah.
Now the residual risk we are telling after the recommendations complied, then we'll see the residual risk.
Right.
Correct. Generally initial risk once before controls. Then after controls, residual risk. Any other recommendation you are giving, even though it is acceptable, then further we'll see. Generally, the initial risk will be before the existing control, so that always risk will be much more higher, little bit higher before the controls, after the controls. Now the second thing in this flow chart itself, what do you call this is flow chart or whatever your HAZOP sheet. On the top, yeah, sorry, on the top you said static is not considered. Am I correct?
Yeah. There is a, but we have considered in this seat, right?
Exactly. See,
Yeah, yeah,
I'm telling again, it's not a fault finding. Okay.
yeah. It's just a typing error. I have also observed that during that
Yeah. Yeah,
discussion.
because any solvents flowing from a tank to reactor, definitely there will be a static
Okay. Right.
generation. So
Right.
that static need to be considered as it is. You have considered in the this parameters, but
Yeah.
I've seen that you have
Yeah.
considered in the parameters, but need to consider there also in place of Na we must write Y, right?
Right.
Otherwise this is good. Sorry to interrupt you. We can proceed
No,
further.
it's welcome. Actually, HAZOP is we can say that we have to pro approach basis. So
Yeah.
before evaluating our rating, risk rating, we have to consider what the existing safeguards we have. Based on that, there are the multiple safeguards are provided. That's why the risk rating, initial risk rating is lower. But you can see in this sheet, you can I have mentioned that risk level D and E is not acceptable risk. In that case, the recommendation is compulsory to reduce the risk. So there is a C, uh, grade is a C. So we don't have required any additional recommendation because of existing safeguards are sufficient to control that risk. So what the existing controls we have provided during the process designing should be considered before that installation, before that designing, and before that procurement and process finalization. So existing system, after that where we are right now, based on that existing safeguard, and after discussion and after suggestions and after so many communications and other suggestions, then after some of the control measures will be additionally we got from the teams. So that will be after a recommendation and for the risk reduction. Can we move?
Yeah,
Yes,
please, sir.
Doctor, please go
Please
ahead.
go ahead. Please go
Yeah,
ahead.
yeah. Okay. Then one of the last we will finish within 5 to 10 minutes. So this is a case study done in Rajasthan in 2009, based due to that particularly sorry particularly due to that leakage of the motor spirit. So in 2009, the Rajasthan IOCL terminal in Jaipur was major leakage. That leak remained uncontrolled for the
The
approximately
case
70.
study, the case study is
Case
not
study.
visible, sir. Are you
Case study
showing
not
that?
visible.
Sorry,
Case
Case
study
study
not
is not
visible.
visible. Only your
okay,
HAZOP sheet is visible.
just a minute. Okay, now it is visible.
Yeah, yeah.
Yes, please. Yes, please.
Yeah. So in 2009, the IOC terminal in Jaipur have a major leakage in gasoline motor spirit, and due to that, there is a major vapor cloud fire, and due to that, many of the people, I think around 11 fatalities was there. The leak remained uncontrolled for approximate 75 minutes, resulting in the formatting of a large flammable vapor cloud. So the vapor cloud subsequently ignite, causing a several vapor cloud explosion, followed by the multiple tank fire throughout the terminal. There is a multiple storage of the flammable and petroleum products, and due to that, when the leakage was happen, so there is so many reasons behind that. The detection part also, it is not under observations. When it is detected, that at that time it is already spread out much more, and when the people is going for the control, at that time the vapor cloud is already happen at covered much far area. And after that, when the some of due to the static charge, the of vapor cloud explosion was happen. And after due to that scenario and that accident, almost 11 people's get the fatal, and nearly around, we can say that continuously the fire happened, and the firefighters are there for 11 days to control that fire and extinguish. So basically there is some parts also there that missed, because we can say that the petroleum industries have a good process designing and controls. So but even that controls the that type of incident, major accidents are happen. So I can say that what was the in that particularly that's some outcome was there, and some investigation part that I have summarized, that there is a position of wrong wall. As per that operator says that there is a the wall is the position is like that, the people cannot uh, approach to that wall to close and to control that leakage. So basically we can say that the design part and operation part and practical part was not considered during that designing. Same second part was there, the human during lineup, loss of containment, like adequate bund dikes and around storage tanks should be considered. Install spill control and drainage system. Like in case of any leakage, should be immediately control and immediately transfer to the another storage tanks. So it cannot liberate and cannot create a hydrocarbons surrounding area. So prevent release hydrocarbon from the spreading over the large area. So vapor due to that the vapor cloud was done. A valve opening in inadvertently hydrocarbon leak. So basically these three part I have covered into one point, that one of the hydrocarbon leak, large vapor cloud formation, and fire and explosion. So basically the install hydrocarbon gas detector around the tank and manifold and transfer area. So that was a key part in case of any hydrocarbon is found leakage in the storage area. So we can install the hydrocarbon like LEL or any VOC gas detector system, and we can also interlock and control by with the sprinkler system. In case of any ppm level or any percentage level is indicate in the hydrocarbon detector, then it will be automatically start the water spray system. So whatever the solvent or chemical are sprayed out, it will be diluted and the vapor cloud can be controlled. Then use remote operated monitor for the vapor suppressions. In that, particularly fatals that 11 people. So there is a tank farm area. So basically, there are too much lesser people are there. But during the leakage, the people are going for that uh, leakage control, and suddenly the vapor cloud fire happened, and the people who are going for the control, they are died, and they are the fatal people. So the remote operated monitor for the vapor suppression, like we can say that the firefighting system should be should be provided. Even we can say that whatever the auto control valve, xv valve, manual valve, we can avoid, and we can provide that particularly for the leakage part will be operating system, DCS operating system. Consider the fixed form system in high risk area, like what we I have told that, or robot type form type system is there in market, so we can also apply. So we our motto should be there in case of emergency also. The less people should be in emergency site, so the in case of any abnormality will be happen, the minimum injuries or minimum impact on the human. So it should be also considered. Operate critical valve remotely from the control room. Reduce operator explosion during the emergency. Already we discussed. And enable remote isolation during the hydrocarbon release. So, we can say that emergency control parameters fail to open to fail. In case pressurized reaction, I have to open our venting system. So, it in case of emergency, the venting system should be on. In case of any cooling system is required or any steam system is should be closed, so that should be decided in one push button should be there. In even in case of emergency, the people push the single button, and what the things should be open and what the things should be closed should be predefined. Same the emergency failure and is there. So I think during the startup of, and we have discussed about the document part, that here we have mentioned that the QRA, that quantitative risk assessment, that's a LOPA, effective emergency preparedness plan. Even we have in the DTA test also we have discussed in that sheet, HAZOP sheet. So basically that type of things we have to, that type of documents we have to consider during the HAZOP study. Same one of the magnetic patch for the leakage. I am just sharing one information. If it is, it can be open. Sorry, but so this link is not getting open. But you can search on your YouTube also, that magnetic patch. In case of leakage, it is a good thing to for the smaller leakage, and some in case of emergency, it is good. So you can adopt in your industries, and it is we are also using this thing. magnetic patch, and it is very helpful for the leakage part. So the link is not open, but you can go to the YouTube and magnetic patch you can mention. So basically, the in PSM part, there is a major role in PSM, like HAZOP, part of the process hazard analysis. What we have started, the PHA is a main part. HAZOP result feed into the operating procedure training, LRM, and trip designs, management of change. HAZOP must be repeated periodically. Sometimes in any of the small changes should be also covered in the HAZOP by MOC. And even your process is healthy and there is no changes, but depending upon your industry and based on your SOP, you can decide your frequency to review and monitoring and revise your HAZOP study. And action tracking recommendation must be closed, not just for the return. As before starting, I just told that most of the recommendation is conclude, but only in HAZOP study report, not in practicality. So it should not be done. It should be complied. The best practices for the HAZOP is include people who really operate and maintain the plant. So bottom people or ground level people should be also the part of the team, because the practical approach we can consider from that person. Use updated PNID. Some and old drawings give wrong results, so all documents should be up to date. Experienced facilitator keep the discussion focused and honest. Sometimes we are hiding some things, we are not disclose the processes that cannot be helped to for the best HAZOP. So it should be disclosed and be honest for that to disclose the process. No blame culture. Every what if question is welcome. Sometimes this is not my point, this is not my it is not look up my point. So this not to be happen on blaming culture, but we are working as a one team, and when we are asking multiple questions, then we can get some of the ideas and some of the risk also. Be specified in the recommendation who will do what and by when. What we have to when we are recommended anything, so who will comply that point, uh, how we can comply, when we have to complete, so that should be specified. Close all action and verify them in a field. So whatever the suggestions are there should be updated into all the documents like PNID, in your procedures, your in process flow diagram, and all the revised document, and practically physically it is provided in field or not should be verified. Keep session short, 4 to 6 hours per day. If you are doing from 9 to 9, then no one will be interested in this HAZOP. Same like I think people are also tired due to that training also, because we are continuous from 1.5 or 1.5 whatever. So, but it should be minimum time, so that can be a healthy discussion. Six things to be remembered during the HAZOP. The team study to find out what can go wrong before it goes wrong. Hazard already presence, so we have to know, we are already know that there is something is there. So we have to conclude with the deviation. Guidewords should be used. Every deviation that should be cause consequence and safeguard. This in this form only. HAZOP is a key part to process safety management, not a one-time event. So sometimes the book is prepared for the HAZOP study and it is lock and key into the cupboard. That should not be covered. It should be communicate when the people are changed, when the people comes in new and any of the goes wrong things, then should be the HAZOP should be reviewed. Good team, good document, close actions, effective risk reduction. If the things should be in mind, that good team we have, good documentation and good updated document and close actions we are taking, then risk definitely the risk will be reduced. So I'm concluding my presentation and my whatever the ideas I have. So whatever the questions and discussions, we are open for that.
Sir, I want to just ask some question regarding the lesson learned from Jaipur incident.
Yeah.
What are the root cause of the incident? What we learned the lesson learned? What are the lessons learned from that particular specific incident in Jaipur fire?
Yeah, actually, there is a major leakage, and the corrective action and investigation report I have referred. There is a two three things that the leakage was happen, and when the people are going for the leakage again, at that time there is a approach was very difficult to close that leakage. So first of all, that the process designing part was very not considered during the designing, because it is a practical approach. Then no one is considered that in case of leakage, how the people was, the installation part was not feasible at that location. Second thing, when the it is explode, and when it is leakage was observed, it is around 75 minutes was completed before the leakage was started. So the detection part was not there, like when the leakage was upon, any of the detector was there, any of the things that like I have told, that LEL or VOC meter was installed at there, and the controlling or any part alarm part was provided in that DCS or local remote area, so that people can be aware that something was wrong, and initial leakage was detected by the people. Third was due to that the vapor cloud was there, and there is a no any system for the automatic sprinkler system or any um, all the things was manual, so people have to go there and start the firefighting or start the dilution for that solvent. So basically that three four things was there. There is a majorly missing in that accident.
Okay, sir.
Yeah, thank you. Thank you very much, Doctor. Can you hear me?
Yeah.
Yeah. So, on behalf of ASSP Kuwait chapter, I thank one and all for being with us. And mashallah, it was a really excellent, marvelous presentation. And the time what we have spent now, it is more than 1.5 hour. That presentation, it was looking like just now we started the presentation. Mashallah, it was really excellent. And Doctor, really, you were arresting the concentration of more than 100 participants. Mashallah, it was really excellent, excellent thing. I wanted to describe everything, but since the time is already 9 o'clock, and in India it is 11:30, and from different parts of the globe there are participants. And since the topic was so interesting, and Doctor made it really this topic very interesting. So, inshallah, this one, everyone, I think many of the safety professionals, they got benefited from this. And thank you very much for giving time for us. And this one, as you know, as you said, this one has it is not individual discipline study, it is a multidisciplinary study. So every discipline is involved in this study, and it is pre-active. Like as safety professionals, we are pre-active always. So even this study, it is before the incident to happen, we are studying this one. Okay, so really this one, to keep the plant healthy, we need to do this study, and it's very important to keep the plant healthy. And with that itself, like see, as you know, it is health is wealth.
Right.
So this study is required for every stage. So jazakallah khair, and thank you for your support. And friends, join your hands with ASSP and try to acquire more knowledge. And this will be having every month, we'll be conducting the technical meets, and we are having the trainings. So you can just make use of this one. You can just attend the trainings and you can acquire the knowledge. So I thank one and all for being with us. And since the doctor is in India, so we like to give a small token of appreciation.
Before that, excuse me, yeah. Before that,
Please.
I think you can see my screen. There is a QR barcode there for feedback form. please scan and fill the feedback form. Then only you will receive the e-certificate of participation.
Yeah, this is very important. As our senior executive said, you can scan this barcode and just you can just answer to that one. Then only the certificate will be issued from ASSP. So this one from different part of the globe, people they can get our certificate as a participation. Okay, so
Mr.
you can just
Yusuf, this is
yeah,
Dr. Siva.
yes,
This is Dr.
yeah,
Siva. I
doctor.
take 1 minute. I have 3 questions. I'm waiting that I get opportunity.
Yeah,
I
please,
hope
doctor.
Q&A is there. These three questions. These 3 questions to Doctor. Doctor, your presentation is good, but I have 3 questions. Maybe it will be helpful to the larger audience. Number one,
Yes.
the artificial intelligence AI
Yeah.
is going with a very high speed and jet speed, I can say.
Yes.
So
Yes.
how we
Yes.
can look this AI into HAZOP? If we
Yeah.
put HAZOP, that means the team and I think errors can be reduced more faster, more reliable, and more integrity we can see. So that's the way I am seeing. So you can maybe respond to that question. Number one.
Yeah.
Number
Actually,
two.
yeah.
Okay. I'll put the question second also.
Yeah.
Second one is a general one. Like in the HAZOP team, invariably they will call the HSC person. Okay,
Right.
he's the part of the HAZOP team. What should be his competencies? How
Right.
he can improve his competencies? The way you presented, many parameters, right?
Right.
They should have honestly, they should have the process safety related competencies. How they can improve upon. The
Right.
third one is what are the standards on the HAZOP?
Okay.
So these are the 3 questions. I thought maybe larger audience may get benefit out of this. And regarding the Jaipur fire is concerned, the walls operation, the design of the walls are the main reason. That is, the MOVs are the main cause. The people have to go inside the tank dike and operate. And after this incident, the major incident, Dr. M.B. Lal committee, 101 or 110 recommendations they have given out of that.
Yeah.
The major is we must have the 2 MOVs in line, and the operation should be at the localized one, not only from the control room. So the entire
Right.
design it has to be should have been revised. So rest
Right.
all you have covered. I thought these points would be helpful to the larger audience. Now you can go ahead with
Yeah.
AI part. How
First
do you
of
see?
all, your first question for the regarding AI. So
Yeah.
right now we can get the idea about that HAZOP, or particularly for something regarding any of the guide work for any of the approach or any of the calculation part also. But
Okay.
we cannot liable on the AI because of the process what we have, that are some practical approaches are there, some practical observations during our lab trials, our pilot trials, during our in our processes. So that is a visible part, and this is a on small scale of base observations that should be covered in our HAZOP study. But when we are go with the AI, so we can use as a tool for to improve or any get any ideas for any suggestions, but we cannot liable on that particular for the AI. That is my suggestion. But because even I have completed more than 40 HAZOP, but I never use AI for that. Particularly, I am also using, but for that any calculation or any methodology that even can help in depth, so we can use it, but not for the liability for 100% on AI. Secondly, for that I think second question was about the hazard, right?
No. The HSC professional competency,
Yeah.
that
Yeah,
is a
competence.
major
Yeah,
contributor for
basically.
the HAZOP, right?
Yeah,
Yeah.
basically we can say that the person who are from the EHS department, he has first of all I can say that he has to particularly he has own interest in process. Otherwise, he cannot do the HAZOP. So first
Perfect.
competency, I can say that the interest in the process should be there. So if he has some interest about the process, about the parameter, about the reactions, about the chemistry, then he can involve and he can understand what is the process, how it work and how it react, and he can understand the chemistry. So basically, in chemical industry, HAZOP is based on chemistry. If you know the chemistry, you can betterly conduct the HAZOP and betterly suggest the ideas. Second thing is for the competency, the basic engineering controls. So normally the engineering parts is a major in HAZOP study. So what type of technologies, what type of innovations right now in working in our industries, what type of new developments are there. So he should be updated and continuously in touch with that technologies, so he can update and suggest more good ideas about that controls. Uh,
Very
Similarly, and similarly, we can say the standards. There are so many like standards. We can say that people are using one of the I think GHS also using for that using HAZOP studies. Some
okay.
of the peoples are also implementing in their own SOPs and own worksheets. But the criteria what we have seen in our study, so it is basically the that parts deviation part that there are different worksheet and different methodology people are using. So basically that should be covered in that particular worksheet and that, SOPs.
All right. Thank you very much. Yeah.
And one of the things that you have mentioned that in about incident 2009, but
Yeah.
we can say that 2009 in 2010 more, I think more than so many people are there, they are more elder than me, so they are very well know about that in 2009 how was the technology and how the people are working in industries. So at that time there are no any automation, no technologies are there. So basically the technology gap was the major accident cause, we can say.
Correct. Thank you very much. Yeah. Thank you, Mr. Yusuf.
Thank you, Pinky sir. Really, the one which was lagging, really, this one, see, as you know, this one for the food, the pickle gives the complete taste of the main course. Really, that was the thing, it was added here. So thank you very much. And see, we had to go along with the technology. Means as the things are developing, we should also develop. So this is also one of the thing which is required. Anyhow, this one, thank you very much for adding up this one. Like it is for everyone. Like more than 100 participants, they have got benefited from this. Like the questions what you raised. So thank you for being
I'm
this
also
one.
thankful that your team has have make a good effort that so many participants are there, and I can share that my knowledge to that people. So it's a great teamwork by all of you, and I really appreciate your hard work.
Thank you, Dr. Siddharth Singh. This is a small token of appreciation. The certificate from American Society of Safety Professionals for you. This will be sent through your email, to your email, inshallah.
Yeah, thank you
Okay,
very much.
thank you.
Thank you so much, very.
Thank you very much, doctor. And thank you one and all for attending this valuable HAZOP study presentation. Thank you.
Thank you so much.
Assalamualaikum, Yusuf bhai.
Walaikum salam.
Want to take
And
1 minute.
special thanks, yeah. Ji.
First of all, thanks to ASSP Kuwait chapter, thanks to your team, thanks to your technical team led by Salman, and thanks your executive committee, coordinator and all. Mashallah, this is a first webinar during your tenure, and Alhamdulillah, I had seen the enthusiasm really keep going on, and thanks to Dr. Siddharth who has given a wonderful presentation.
from starting actually from the history of HAZOP till case study, he has covered everything. Thanks to Doctor and thanks to Dr. Pinky and all our team member of ASSP Kuwait. Wallah, this is really very good. Many groups we had said this invitation and they had participated, and many groups are requested to get presentation. I am also requesting that if possible, just to share this presentation, so the participant will get more benefit. Thank you, Mr. Yusuf.
Thank you. Jazakallah khair, Mr.
And
Zahid Thakur.
special thanks to your technical team and behind the scene, the person who brought the speakers on this platform, Mr. Huzaifa and Mr. Salman Warhanuddin, Iftikhar and all technical team. Jazakallah khair.
No, really, mashallah, it was a very good job done by our technical team. Mashallah, it was really excellent and keep going. And inshallah, see, knowledge sharing, it's our main concern. So inshallah, we shall share as much as we could. So that's our aim and that's our target. Inshallah, we shall do in the same way. Inshallah. Jazakallah khair for everyone. And since it's late night in India, so I don't want to just elaborate. So inshallah, we'll end by this. Inshallah. Thank you. Thank you. Thanks a lot. Thank you.
Thank you, everyone. Thank you. Yeah. We are closing the meeting now.